Okay, so here in example number 4, we're focusing on a process where we are reacting HCl and oxygen to form chlorine with a byproduct of water. And for this process to work, you also have to feed air into the process, and the oxygen from the air is used to power the reaction, or for the reaction. So let's write out that actual reaction happening. So HCl plus O2 gives us Cl2 plus H2O. And we need to balance this, so we're gonna have 2 HCl and half mole of O2. So we did the reaction. Now we're gonna draw out a flow chart. So our reactor looks like this, where we have 2 inlet streams. So like I mentioned, we have a stream with air, and the oxygen from that stream is used within the reaction. And we're feeding air, sufficient air, at 35% excess oxygen. So this is our air stream. And that's 21% O2 and 79% N2. And then we also have 100 moles of HCl entering the process. And then leaving the process, we have 1 stream, and that's going to have 5 different components in it. So it's going to have some number of moles of unreacted HCl, some number of moles of unreacted oxygen, some number of moles unreacted nitrogen, since the nitrogen we have going in is the same amount we have going out, because that does not react within the process. And then some number of moles of formed Cl2, as well as water. And then a degree of freedom analysis on this process. So we have 6 unknowns. So that's N1 through N6. And then we have 4 balances. Those are on H, Cl, O, and N. We have 2 pieces of info, which are, we're told that, so we have X5, as well as the fractional conversion. Okay, and now we are going to go ahead and start solving using the atomic species balances. So first we're going to use the piece of additional info, which is about our oxygen. So number of moles of O2 is equal to 100 moles HCl. And this is how, so we're figuring out right now how much oxygen we need to react, just to react with the HCl. So 100 moles of HCl are fed to the process, and half a mole of O2 reacts per 2 moles of HCl. So in order to react 100 moles of HCl, we would need 25 moles of oxygen, theoretically. Now we're going to use that piece of information where we're told that air is fed in 35% excess. So using that information, we can figure out that if we have 25 moles of O2, theoretically, or we need 25 moles theoretically, and 1 mole of air has 0.21 moles of O2, then theoretically we require 119.04 moles of air. Again, this is theoretical. And then we know that we are feeding to the process 35% excess, so we can use our percent excess formula to figure out how much air we are actually feeding to the process, with that being in 35% excess. And for that we get that we are feeding 268.7 moles of air to the process. That doesn't seem right. It's because I wrote this wrong. Sorry about that. So it's 119 moles. Again, sorry. So 0.35 times 119.04 plus 119.04. Okay, yeah, that seems right. So we're feeding 160.7 moles of air to the process, and that is N1. Now we're going to use the fractional conversion in order to figure out N2. So to figure out N2, like I said, we're using fractional conversion. So 85% of the HCl is reacting. So we know that 15% isn't reacting, and that is what is left in the N2 stream. So 1 minus 0.85 times 100 is equal to N2. So we know that N2 is equal to 15 moles of HCl.